Hey guys, I'm Manoj. Welcome to this chapter from the course C# and .NET for Beginners. I create contents for developers. Subscribe to my channel and press the bell icon to get the latest updates from this channel. We have seen variable declarations and data types. We also used Console.ReadLine for printing the values. In this chapter, we will start discussion with the concept of type conversions. Then, we will see how to read inputs from the user. We will also have a look at how to set font colors for the text that is printed by using Console.ReadLine. Let's begin with the basics that we have covered yet. We declared variables and we used Console.ReadLine to print their values. All those lines of code had one thing in common. Every line of code was ending with a semicolon. In C#, every statement of code ends with a semicolon. Let's have a look at two new commonly used concepts, expressions and statements. An expression is something that evaluates to some value. For example, a plus b or a plus b minus c. These statements will evaluate to some numeric value. Subtracting a time-only variable from another time-only variable will also evaluate to a value of type timespan. Expressions can also be nested together. For example, a minus b is one expression, c multiplied by d is another expression, and we can nest them together for a division operation. And then let's have a look at what a statement is. A statement does not return a value but does something. For example, Console.ReadLine is a statement because it prints the text, but it actually does not return any value. Okay, let's move on to the next section. Let's have a look at the exercises from the last chapter. Did you get chance to try them? First, second and fourth exercises were easy, but the third exercise was a bit tricky. Let's start our discussion with that exercise. The exercise was to create a decimal variable x and a double variable y and then perform some arithmetic operation. So let's add a statement to add x and y and store the result in some variable. Now let's try to run the program. We get the compilation error. The error says that the operator plus cannot be applied to operands of type double and decimal. Operand is the new word here. Let's understand what it is. Every line of code in the program is an individual instruction. An operand is part of instruction which specifies the data to be manipulated or operated on. So, in case of this line, these two variables specify the numbers which should be operated on, and that's why those two variables are operands. This error is saying that we cannot perform addition of these two variables because the data types are not matching. So what can be done here? We already know that the type of a variable cannot be changed at runtime. Of course, we can modify our program and then change the data type of one of the variables so that the data types match and program would function as expected. But in real world programs, we may not have such flexibility to change data types as per our wish. And that's why in such scenarios, we use type conversions. Type conversion can either be done by using typecasting or by using a helper class. Typecasting is used for converting a value of a given type to a value of another type. Typecasting can either be implicit or explicit. Let's see what is implicit typecasting. Implicit typecasting is simple. It doesn't require any extra syntax and it doesn't cause any data loss. An implicit casting can be made when a value to be stored can fit in the target type without being truncated or rounded off. For built-in numeric types, it means if the range of a source type is a subset of range of the target type, then implicit conversion can happen. For example, byte variable can be assigned to a short variable without any problem. And we can also assign a short variable to an int variable without any additional syntax. And similarly, an integer value can be assigned to a long value. In explicit typecasting, expression like this in bracket t followed by e is used, where t is the target type and e is the source variable. If no explicit conversion exists from the type of source variable e to the target type, then a compile time error occurs. At runtime, an explicit conversion might not succeed and explicit casting might throw a runtime error. From decimal to double, an explicit cast exists. So, we can just cast our double variable y to decimal type. We can store the typecasted value into a temp variable and then we can use this temp variable for arithmetic operation. Or we can simply drop the temp variable and directly use the typecast expression inside the arithmetic expression. Sometimes type conversion is not possible by using either implicit casting or explicit casting. For example, let's say we create a variable of type string and then assign 10 inside double quotes to that variable. Then if we define another int variable and try to perform explicit typecasting, it will not work. So what can we do now? In such cases, we can use conversion using a helper class. C# provides a helper class convert. We can use a method convert.toInt32 to convert a string to an integer. Note that the conversion would be successful only if string contains only digits. If conversion is not successful, it may result in runtime errors. Runtime errors are also known as exceptions. This convert class also provides many other methods like toString, toInt32, toInt64, toBoolean, etc. But wait, what is int32 and int64 now? So let's start from beginning. .NET implementation is language agnostic. This means that .NET supports multiple languages. Whether you write code in C# or VB.NET or in any other language, when you compile the code, it is converted into an intermediate language code. Runtime only understands intermediate language, and that's how multiple languages are supported by .NET. In order to support flawless, transparent cross-language integration, .NET provides some rules and specifications that every language must follow in order to be supported by .NET. Common Type System is part of those specifications. Common Type System, also known as CTS, describes all the data types that are supported by .NET Runtime. CTS also includes rules that all language must follow when it comes to working with those data types. For example, CTS enforces that int32 can only be 32 bits in size. It is a numeric type, so it should support arithmetic operations. Like this rule, there are many such rules specified in CTS. CTS provides various primitive types as a part of system namespace. When we install .NET SDK, all those types are available for us and we can use them for application development. CTS defines various types in its specifications, and all those types can be categorized into 5 categories: classes, structures, enumerations, interfaces, and delegates. We have covered basic idea about classes in chapter 2. Rest of the types we will cover in coming chapters. .NET Common Type System defines some primitive types like int16, int32, int64, etc. These are all defined by using structures. A .NET language can alias these types. For example, .NET type is int32 for 32-bit integers, but in C# int is an alias for the same type. In VB.NET, integer is the alias for 32-bit integer, and so on. C# has aliased int16 as short, int32 as int, and int64 as long. Similarly, C# types unsigned short, unsigned int, and unsigned long also have their primitive counterparts with prefix u. Bottom line is, short, int, and long are aliases of .NET primitive types int16, int32, and int64. Similarly, ushort, uint, ulong are aliases for unsigned primitive types uint16, uint32, and uint64. They are basically just another names of the same data type. Now let's come back to the type conversions. So for converting a string 10 into integer 10, we just need to use convert.toInt32 and pass string variable inside the brackets as input. Similarly, let's say there is a string variable that contains true in double quotes, and let's say we want to convert it to a boolean type. Then we can call convert.toBoolean method to convert this string into boolean value. In addition to convert class, many types provide methods for type conversions. For example, int provides method int.parse, which can be used to convert a string to an integer. Other numeric types like decimal, double, float also provide similar methods to convert string inputs into numeric value. Numeric values are probably easy to convert. Just some digits and optionally decimal point inside the quotes. Converting from string to datetime is bit tricky. Datetime provides 3 different methods for conversion: parse, TryParse, and ParseExact. These 3 methods can help to parse a string value to a datetime value. Date is specified in different formats in different countries. Sometimes the date is specified in year, month, day format, while in some countries the format may be year, day, and month. Parse method basically takes 2 important parameters: a string value which needs to be converted and the culture info, which would tell .NET how string value should be parsed. The culture info would tell which part of string should be considered as date and which part of string should be considered as month and which other part of string should be considered as year, and so on. TryParse method is also similar. It takes string value to be converted and the culture info object. If the conversion is successful, TryParse returns true. and the converted value is returned in the form of an out variable. Parse Exact is another method which can be used to convert a string value into a datetime value. Parse Exact also has two parameters, the actual string value which needs to be converted and the format which should be used to parse the string. This format may contain letters. Lowercase d is for day. So 2 D's means date will always contain 2 digits starting from 01 till 31. Uppercase M is for month. 2 M's specify the month number and that number will always contain 2 digits. Lowercase y is for years. 4 occurrences of y specify that year would be specified by 4 digits. Optionally, we can also specify the time part. Uppercase h can be used to specify hours in 24-hour format. Lowercase m can be used to specify the minutes part of time, and lowercase s can be used to specify the 2 digits of seconds. Optionally, we can also specify a separator like a backslash character or a hyphen or just a white space to separate different components of date part and time part. So let's say we want to convert a string value 26 January 2022 into a date time. So let's say the value was specified like this. Now if you want to convert this into a datetime value, then we can use datetime.parseExact and then pass the input string value as the first parameter, and then we can specify the format dd mm yyyy and it should convert the string value to a datetime value. We can also add the time part if required. This should give you idea about how to convert a string value to a date only or time only type. I think we have covered all the basics of converting a built-in type into another. Let's move to the next part to understand how to read inputs from the user. In console applications, we can use console class for reading from the console as well as printing something to the console. In this chapter, we are going to discuss three methods: Console.ReadLine, Console.ReadKey and Console.Read. Console.ReadLine is simple. When .NET is executing this line of code, the console provides a cursor and we can start typing the input. We can keep typing until we hit enter. When we hit enter, all the characters that we entered are returned as a string. If we press enter without providing any input, then it would return an empty string. The second method is Console.ReadKey. When .NET is executing this line of code, it will allow user to type something. But the difference is it will only wait for single key to be pressed by the user. It does not wait for user to press the enter. So as soon as you press the key, next line of code would be executed. The return type of this method is console key info, which is a struct. This returned value contains information about the character that was pressed. Console.read is the third method that we want to have a look at. When .NET is executing console.read, it also provides a cursor on the console and we can type anything that we want. This method waits until we press enter key, but it will return only the first character that we have entered. That's how it is different from Console.ReadLine. Console.ReadLine provides the entire input until the enter was pressed, while Console.read provides a single character that we have entered. In fact, the first character that we have entered on the console. The return type of this method Console.read is integer, so it will return the integer value for the corresponding character. Console class also provides methods to alter font color of the text that will be printed. Console.foreground color is used for that purpose. We can set this property to any color of our choice. If we want the default colors back, then we can just call Console.resetColor method. Similarly, console class provides two methods to print the text. One is Console.WriteLine that we already have seen, and the another is Console.Write. So what is the difference? Console.WriteLine prints the text and then also prints a new line character. So anything that you print after would be printed on the next line. And Console.Write just prints the text that we have passed. It doesn't print the new line character. So if you call Console.Write multiple times one after the other, all the text would be printed on the same line. Now let's write some code. We are going to write a code which asks 3 questions and the program will also allow to input the answers. Let's say in the first question we want to ask the name of the user. So let's add a Console.WriteLine and pass the text, what is your name? This text will be printed on console window. Now we need to allow user to enter the name. Name can contain multiple characters and we want all those characters to be returned. So in this case we are going to use Console.ReadLine. The return type of this method is string and we are going to store this string value into a variable called as name. Note that although we have used var here for declaring the name variable, compiler can derive its type to be string as the right side expression Console.ReadLine returns a string. Now let's add another question. asking about date of birth. So another console.WriteLine, and we will pass the text asking for date of birth of the user in DD, MM, YYYY format. Date of birth can also contain multiple characters. So again, in this case, we will use console.readline and store the returned string value into a variable called as string date of birth. Let's use type conversion now to convert this string date of birth into a date only type. We will use dateOnly.parseExact method, and we will pass the input value and the expected date time format DD, MM, YYYY. This should convert string date of birth into date only type. Now let's ask another question. Let's say we want to ask user how many languages the user can speak. So another console.WriteLine to print the question. The number of languages can be any number. It can contain multiple characters if the number is greater than, let's say, 10. Let's say if user knows more than 10 languages. And that's why here also we are going to use console.readline, which will return us a string value, and then we can use convert class to convert the input value into an integer. Now let's try to print all the parsed values on the console. To identify the area where we are printing parsed input values, we will set foreground color, that is the font color, to be yellow. Note that foreground color is a property and it can be set to any value from console color enum. Console color enum contains a lot of different values, each representing a different color. Let's select yellow from the list and then add 3 console.WriteLine to print the parsed values: name, date of birth, and number of languages user can speak. Till now we have used only console.readline, which returns multiple characters entered by the user. We have not used console.ReadKey yet, which returns only a single character. So to demonstrate how to use console.ReadKey, let's try one thing. Let's first reset the console colors to their default values by calling console.resetColor, and then add a console.WriteLine asking user to press any key to exit the program. As this time we need a user to press any single key, we will use console.ReadKey. Also, we do not care which key was entered by the user, so we will not really assign the character value returned by console.ReadKey to any variable. After console.ReadKey, let's add another console.WriteLine to tell user that program is exiting. Now let's try to run the code. Program will ask 3 questions. We can provide answers to those questions. The program will also print the parsed input values in yellow font color. After that, program will ask user to press any key to exit. As soon as we press any key, program will try to execute the next line of code, which prints exiting message on console, and then the program exits. So we have covered how the type conversion works and how inputs can be read from the console. You can also try using console.read instead of console.readKey to understand the difference between those two methods. Below are some exercises that I would recommend you to try on your own. First exercise is take 2 integers as input and then perform arithmetic operations on those 2 numbers. After that, print the results. While printing, you can also try to play with foreground color to print the results in different text colors. Exercise 2 is input 2 decimals and then perform arithmetic operations and then print the results. It is very similar to the first exercise. In second exercise, we are supposed to use decimal as the data type, while in first exercise, we are supposed to use integer as the data type of the 2 numbers. The third exercise is input a single integer and then add int.max value to it and then print the result. Let me know if you get the expected result. Fourth exercise is for calculating simple interest. So input principal amount, duration in number of years, and rate of interest per year, and then calculate the simple interest using the formula P into N into R divided by 100. Try these exercises and let me know if you face any difficulties. Thanks for watching. If you found this content helpful, like this video and subscribe to the channel. If you have any feedback or suggestions, please let me know via comments. Alright, see you in the next chapter. Namaste.